So the partition itself depends on the virtualization host type. We have different types of partitions, or partitions the virtual machines, and depending on which virtualization technology is used, there are different commands to manage the partitions. For example, for Xen we have the XM command. For VMware we have VMware CMD. Linux vServer is using vServer control or something like that. And the different commands and let me start again. When a partition or when a virtual machine in openQRM is going to be rebooted, the normal way of rebooting a physical machine in openQRM is that openQRM sends a reboot command to the machine. If the machine is a partition, it must not send the reboot command directly to the machine, but to its virtualization host. So the virtualization host can then run, for example, XM reboot to reboot the partition. When openQRM, those partition commands are mapped and then executed on behalf of the host resource. Meaning, if we want to reboot a partition, if it's a Xen partition, the reboot command will go to the Xen host, and the Xen host will then run XM reboot. If the virtualization host is a VMware host, it will run VMware command reboot. So the administration itself for virtual machines is just like for physical servers, because those mapping is completely transparent to the user, and it just say to the sysadmin, he just can say reboot this machine, and either if it's virtual or physical, it will reboot. Partitions then can also move easily from one virtualization host to another. I just said it, we can build clusters of virtualization hosts and then move either live migrate or cold migrate virtual machines from one host to another. Another advantage of openQRM in general is that you have an integrated resource management, which also covers your virtual machines. Meaning you have in openQRM a list of available machines which can be used for deployment. And when you created some new virtual machines, they will just come up in this list as new available resources ready for deployment. They are just not from the type physical machine, but from the type partition. And if it's a VMware, it's a VMware partition, or Xen, it's a Xen partition from different types. So let me tell you a bit more about the specific implementations of the different virtualization technologies in openQRM. We first integrated with Xen because it's a famous open source virtualization product. The openQRM can automatically deploy Xen hosts, and on the host you can then create virtual machines. And for each virtual machine we have configuration page where you can change the configuration of the virtual machines on the fly. This is all integrated within the openQRM user interface. There's also a Xen console where you can access the command line from the partition from within the web interface. And yeah, the Xen plugin also supports live migration. So here's a screenshot from Xen configuration page of an already existing partition. In general, partitions are being created within openQRM in a similar way or in the same way for all virtualization types. That means in openQRM we have a page for creating partitions, And this looks the same. This looks the same if it's VMware, Xen, QEMU, or Linux vServer. There's no difference. The difference for the configurations are, let me start again. For each virtualization type, we then have different configuration options, of course, which are implemented in a separate page for each virtualization type. So this is the Xen console within the openQRM user interface. So we directly can access the partitions command line. So then there's the QEMU plugin. Also, openQRM automatically deploys your QEMU virtualization host for then creating partitions on it. openQRM supports the KQEMU acceleration module and also KVM. It means you can run the QEMU plugin with full virtualization in openQRM. Then we have the Linux vServer plugin. Linux vServer is a very light virtualization type based on isolation, and it's very useful for creating lots of small virtual machines. For example, for a web hosting company, those Linux vServer virtual machines have very, very less overhead. We also have the VMware plugin. It's provided by Clusters, who is doing some commercial plugins and add-ons for openQRM. It manages existing VMware server. That means it does not deploy VMware ESX or GSX server, but you can manage your existing VMware servers with it, and it's based on the VMware API. So a typical reference installation for openQRM is it makes sense to have the openQRM server itself running in a high available setup, means an active passive standby, because you don't want to lose your data center management system and create a single point of failure. We also recommended a distributed setup using a remote database, if possible, a high available database, and of course dedicated storage servers for providing the fast cloning features, for example. We also interface with Nagios. That means we have a plugin for enhanced monitoring with it, and since the virtual machines in openQRM are abstracted and handled in the same way as physical machines, also all the additional plugins for managing systems with openQRM can be used for the virtual machines too. For storage server integration, we recommend the LVM plugin, which provides fast cloning features. So if you don't want to spend your money on NetApp, you just can simply transform a standard Linux box into a fast cloning storage server for openQRM using the LVM management plugin. So we're having this appliance-based deployment, which we are concentrating